Okay, so in the previous video we were introduced to this concept of inverses, but the problem was we had no way to identify an inverse to keep it separate from the original function. For example, you had an equation like this where we had y equals 2x plus 5, and we found the inverse of it by switching the x and the y around and then solving for y. So we would subtract 5 from both sides, giving us x minus 5 equals 2y. Divide both sides by 2, and you end up getting y equals x minus 5 divided by 2. Well, that's the inverse of y equals 2x plus 5. But when you compare these two, there's no way to tell one from the other. So that's why we have to have a special way to be able to identify the inverse. And that's what we're going to focus on now. Now, if you notice, so in this top section here, it says how to identify an inverse. It says we use f of x to identify a function. That's what we've been dealing with in the last couple of videos and the last couple of lessons here, is we've been looking at things in function notation. So you're familiar with seeing things written as f of x. Now, to identify the inverse, we use this exponent of -1. Now, if we're dealing with, if the name of our function is f or g or h, that's what our function's going to be named. So in this case here, if we're dealing with f of x, the inverse of that would be f, and then we use that exponent of -1 of x. Now, we don't say f inverse of -1 or f exponent of -1. The way that we read that is we read it as the inverse of f of x, or the f inverse of x. But we use that to identify the inverse of a function. So we use f of x to identify a function, and we use that negative exponent of 1 to identify the inverse of a function. So for example, let's look at this one here. We have f of x equals 2x plus 8. We're going to find the inverse here. That's our goal. Now basically we're going to do this in a three-step process, or a four-step process. The first step, well, we know that to find the inverse we switch the x and the y. Well, here I don't have a y. I have f of x equals 2 times x plus 8, but there's no y. So we're going to change this, because right now it's in function notation. Remember, f of x replaced y. So I'm going to put this back to be in the form y equals. So it's going to be y equals 2x plus 8. And now what we're going to do is we can switch the x and the y around. So it's going to be x equals 2y plus 8, because what we just did is we just found the inverse. So by switching the x and y, that does find the inverse, but we don't leave it like this. We want to put it back into function notation, so we have to get the y by itself. So the next step is going to be to solve for y. So to do that, I'm going to start by subtracting 8 from both sides. So that gives me x equals 2y, x minus 8 equals 2y. And now I want to get the y by itself by dividing both sides by 2. When I do that, I get y equals x minus 8 all divided by 2. But the problem is I don't write it, I don't have my answer in function notation. So my last step, my fourth step here, is to write as the inverse of f of x. So my answer would be this. Because now when I look at my first function here, you can see that the original function was function f, which is 2x plus 8. The inverse of function f would be x minus 8 divided by 2. So what we're doing today is very similar to what we did in the previous lesson. It's just that we're putting things into function notation. Like here I have g of x, so this time we're calling this function g. So we're going to follow that same four-step process. Our first step is to write this as y equals. So it's going to be y equals negative 4x minus 12. The next step would be to switch the x and the y around to find the inverse. This would be x equals negative 4y minus 12. Remember, even though technically we have found the inverse here, we want to get it in function notation. So I want to add 12 to both sides. And then I'm going to divide both sides by negative 4. So I would say y equals x plus 12 all divided by negative 4. But remember, I don't want to leave it like this. I want to put this in function notation. So instead, now this is function g. So I'm going to say g inverse, the inverse of g of x is x plus 12 divided by negative 4. So that's my answer. So your answers here should always be, if it's written in function notation, your answer should always be put back into function notation, but we identify the inverse with that exponent of -1. Let's look at another example with fractions. Because here they give us one that's written kind of like the answer that we got in the previous one. So we want to figure out what would the inverse of this function be. So the process is still the same. So we're going to start by writing this in the form y equals. So it'll be y equals 8 plus 3x all divided by 4. Next we switch the x and the y. So it's going to be x equals 8 plus 3y all divided by 4. And now we solve for y. We're going to do that by multiplying both sides by 4. So now this one looks more like what we were dealing with before. Again, what we just did here is we multiplied both sides by 4. That gets rid of the fraction. So now I want to do the next step, which would be to get rid of the 8. So I'm going to subtract 8 from both sides. So that's going to give me 4x minus 8 equals 3y. And now I want to get the y by itself, so I divide both sides by 3. So my answer would be y equals 4x minus 8, all divided by 3. Again, I don't want to have this as y equals. I want to put this back into function notation. Since we're dealing with our function name is f here, this would be the inverse of f of x equals 4x minus 8, all divided by 3, and that's your answer. So why don't you guys, if you haven't done so already, get out your assignments or print them out from online, because I do want to look at one of them on the worksheet. And the one I want to look at is this one here, number 4. We're going to find the inverse here. So what we're going to do is, again, we're going to do the same 4 steps. I'm going to this will make it a little faster. Instead of saying g of n, we're going to say y equals. So now I'm going to switch. Now, even though there is no x here, it's an n, we're going to switch the n and the y. So it'd be n equals 1/2 y minus 5/2. But I don't like having fractions. So to get rid of the fractions, one of the things that we can do is look for a common denominator and multiply both sides by that common denominator. In this case, my common denominator is 2. If there's only one fraction, it's real easy. Whatever the denominator would be for that fraction, that's your common denominator. But here we have 2 fractions, and luckily enough, they both have a denominator of 2, so it makes it a lot easier. So I'm going to multiply both sides by 2. That would give me 2n on the left. On the right side, well, half of 2 is 1, so this would be 1y, or just y. And 5/2 of 2 would be 5, or you can look at it as, when we multiply these together here, we get rid of the 2's. So we'd have 1y minus 5. Now we're going to solve this equation for y by adding 5 to both sides. And we put it in function notation. This function is g, so it'll be the inverse of g. Whoops. Inverse of g of n in this case. If you said x, I wouldn't be too picky with that. But the variable we're using here is n, so it'd be 2n plus 5 is your inverse. So hopefully you can see what we're going to be doing here with inverses and how to write an inverse when it's in function notation. That's very important because you will lose points if you don't include that in your answer. So make sure you're aware of that. So with that, good luck on that assignment.